So I'm recording, so welcome. We are right now in our Design 350 lab. It's Wednesday, 11 o'clock, and and this today we're not taking measurements. We're going to really pay attention to the measurements that we've done already. So what you see here is the results from the field survey from week 5 that were posted by Leah, and it looks pretty good, right? I got all this stuff, and it looks pretty darn straight. So it's good within. If I were actually to get the average of these locations, it would be off by about maybe an inch and a half or 2 inches. So that's certainly well within what we're talking about as we're working here as you're just learning. So now let's take a look and see what I just plotted. I just plotted this data which I took off of her work, and notice I've now put in the elevations, the rod readings. So this is the data that I was given. Now sometimes people make these ones gray because they're actually calculations. And I'll make them a little bit bigger. There we go. So these ones are all calculations. And so we are interested in the instrument height. I'll make that one back smaller so it fits. Okay. And we're interested in the ground elevation from these readings. So we know that the ground elevation was 0 on that first point. Now I'm going to put these back side by side. Okay, we knew that the ground elevation was 0 right there. That's the corner of the building that we chose as project 0. So I can just write that one down. Okay, so in this case, that one can be reset because that one's not a calculation. Okay, that was 0. But then I got my rod reading of 3.46 feet. So that meant that the instrument height for this set was 3.46. Okay, and we know that if I take the instrument height, right, minus the rod reading, this should be instrument height minus the rod reading. What have I got going on there? Oh, sorry. These are not right, are they? So we have our instrument height of 3.46 and a rod reading of 3.94. So I did these ones backwards. Equals the rod reading minus the instrument height. I hate it when these things do. Equals 3.94 minus 3.46. And I just did it backwards again. Equals 3.46 instrument height minus whatever the rod is. So that is 0.48 lower than my original height. Okay? Does that make sense? Because it has to go down below to get to it. And so this one equals 3.46 minus 4.71 minus 1.25, and this one equals 3.46 minus 4.72, 1.26. Okay, so that takes care of those, and I need to go change that on my drawings. This is this one has an elevation of minus 0.48. This one has an elevation of minus 1.25. And this one has an elevation of minus 1.26. Okay, and that's how I get my actual elevation. It's my instrument height minus what my rod reading is. Okay, and we went through that all before, right? And so you know how to do that. Okay, now hopefully I've got the right ones on here. Doesn't really matter, but that's what you'll end up doing, right? You'll get those rod readings correct. Actually, they were inconsistent. I couldn't tell what they were because one of them was off by like a foot and a half from the other one. But we'll see. These two should have been about the same. Okay, but you can go back and you can redo those if you have a problem. Okay, but what's critical is that you get a record that looks like this and that you actually label them over here. Okay, and this point right here was my golly, there is something really wacky about my AutoCAD on this one. I wonder if they've got something weird going on. But that was my first setup. That was my T1 setup, right? So that was my instrument for T1. Now, my next one, now I'm going to move this out of the way. Just going to get it out of the way and over here somewhere. Okay, now I need to do these ones. And I went and took a look at the data and I typed these ones in. Now, look, I started with T2.2 because it's the same as T1.2. And I started with T2.3 because it's the same as T1.3. You don't have to do that, but that's how I know what to realign things to later on. Okay? So that's a personal preference. I could have made it T2.1, 2.2, and made notes about it, right? But this is my own personal preference. So now, look, this was the data that I got. I got distances from my setup and all that kind of stuff. And then I got these things. Okay? Now the trick is these two numbers here, the 4.12 and the 4.18, okay, correspond to a ground elevation. Okay, so the height of my instrument is my ground elevation plus my reading. Over here it was my ground elevation plus my reading. So if I took my ground elevation, and that should have been a minus 1.25, and that should have been a minus 1.26. So these are not correct anymore. Okay. What have I got now? I've got my rod reading plus that, right? So that equals my rod reading, 4.12, minus 1.25, plus minus. And this one is my rod reading equals 4.18 minus 1.26, plus or minus. Now these ones are all going to be the average of those two, or you could pick one that you feel is right. But I'm going to use the average. I can say the average of these two. There is something really wonky about what's going on with my computer right now. It's the average of these two. I don't know what's going on here. There's something really off in where I'm selecting and what's going on. So I'll just
So I have a question
do it
for
by
you.
hand. Yep.
So, could I have the? Oh wait, this is gonna be all on the recording
Yep.
later on.
Yep.
Okay. So I have to say, can I get a copy of the original three measurements plus the T1 so I can reference off them?
Right. Yeah, and they're on there. I took them off of the discussion.
Okay.
So there we go. Okay, so now this one is going to equal my instrument height minus my rod reading. Okay? Instrument height minus rod reading. Instrument height minus rod reading. Instrument height minus rod reading. And right now, all we're doing is we're noting the elevation with text. If you'll notice over here, I'm doing my drawing like I did before, and then I'm just putting text in there. Okay? And we'll change that later on. We're gonna go and change those at another time, but right now, um, we're just doing it with text. I'll show you how to turn this into 3D next week, maybe this week. Okay, so now the next thing to do is to draw these ones in. And I can start anywhere, right? And I'm gonna put, this is my, there's my instrument T2. Okay, and my first one is from the center point at a distance 74.88 at an angle 287D, 35 minutes, 15 seconds. And I don't care where it goes because I'm going to line these up later on. Okay, my next one from that same point is 44.6 at an angle 293D, 42 minutes, and and I don't need to type in the 0 seconds, but I figure I might as well. And look, that's actually coming out pretty cool, because it looks kind of like these 2 points. So when I line them up, it kind of looks like it might be good. Now let's see where we go with the next one. Oh, and I need to get my text in there. So DT, and I don't care. Um, I don't care where your text is oriented or anything. But it's a good idea to get these in as you go. So this one is T 2.1, 2.2, and its elevation is minus 1.25. And remember, the reason I started with 2.2 is that one is the same as 1.2. So it's just my way of making sure that I'm corresponding these things. So this one is T 2.2.3, and it's at an elevation of minus 1.26. Let's see how we do on my next one. From where I'm at, 37.22 at an angle 295. Yep, let me get the right one. There we go. So this is another thing. Usually I highlight it and then go and get it because it stays over there. So here's my line. It's from where I'm at. I need the at symbol. 37.72 at an angle 295 degrees, 42 minutes, 0 seconds. Oh, I typoed. At 37.72 at an angle 295D, 42 minutes and 0 seconds. There we go. Ooh, not sure that one's going quite the right place. We'll have to see. How did that work? Oh, because I wrote this one in as 213 instead of 293. See, all sorts of problems like that, but you can figure them out. What is up with this? Got that off. That's like it's not even close to what I would have typed in. 213. Um, I tell you, my AutoCAD is just really whack doodle right now. Oh, somehow I'm on surveyors. That's why my units are just wrong. It's because my units are wrong. And nothing. Oh, where are they?
We're also on clockwise on our units, right?
Yeah, but I was not in degrees, minutes, and seconds for any of this. So we have to get started all over. I'm not even sure these are right. Um, they could be, but um, for some reason, when I opened this up, I got surveyor's units instead of degrees, minutes, and seconds. So I'm just going to start all over again and try to get this right. So there we go. That's my T1 from where I'm at. 77.85 at an angle of 290D, 32 minutes, 32 seconds. Did I not get clockwise? I'm clockwise. Just feet. Did you use the at symbol? If you're using this weird relative thing down here, the dynamic input, make sure it's off. From where I'm at, 51.05 and an angle 349 degrees for minutes, 28 seconds, and this is T1 datum elevation equals 0.0. And then this one is, and these are too big, but that's okay, T1.1, and its elevation is minus 0.48. And I'm going to make those all just a little bit smaller. So my size here is 5. I'll make them 2. There we go. Yeah, they were lining up, and I just want to get everything squared away right. 21.95, where I'm at, 21.95, and an angle, 93D, 5 minutes, 0 seconds. And that's T1.2. You see, it's just a matter of getting all these things kind of like squared away, and you got to just go one by one by one, minus 1.25. And the last one is from where I'm at, 46.93 at an angle, 126D, 16 minutes, 0 seconds. Yep, and those all look pretty good. And they look like they're in a pretty straight line. That's T1.3. And minus 1.26. Okay, then when I draw my north line over here, I can do my align command. And I know that this one is at the bottom. And this one is at the top. There we go. And they still look like they're in a nice straight line. So that's my T1. I'll just get it out of the way a little bit. And now I'll do my T2, and I'll set it up all separately over here. And I wanted to have this all done for you, but that's okay. We'll just get through it. So it's from where I'm at, 74.88 at an angle, 287D, 35 minutes, 15 seconds. and that's T 2.2, and it's at a minus 1.25. Now let me get my 2.3 from where I'm at, 44.6 at an angle, 293 D, 42 minutes, 0 seconds. And that one becomes T 2.3, right? And it's a minus 1.26. Now let's see, here's the trick, getting our next point in there from where I'm at, 37.72 at an angle 295 degrees, 42 minutes, 0 seconds. That's much better, right? Because that was the corner of the wall. Those would hopefully line in a line. Is that correct from what you guys think of your recollection of what that actually looks like? So that's a good sign. It's always good to have sort of a sketch in your mind or on a piece of paper somewhere. We're not doing that yet. Minus 1.33. Let's see if those do end up being in a line or pretty close. Not far off, a little bit. And remember, that spot there was a little bit weird and janky to try to figure out because it was out in the middle of nowhere. Okay, let's see where our next one goes. From where I'm at, 55.56 at an angle 328 degrees, 42 minutes, 0 seconds. And I did something wrong there. From where I'm at, 55.56 at an angle 328 degrees, 42 minutes, 0 seconds. There we go. And looks kind of like a 90-degree angle. And that's T 2.5. And what we're doing right now is what everybody in the class needs to do. Okay, our next one is from here, from where I'm at. Come over here and figure this one out. $75.88 at an angle 341 degrees, 1 minute 20 seconds. Ooh, that's looking like a 90-degree angle. Actually, really good for your first time getting something like this. And now you're seeing how, like, hey, these are not all that easy. But you're doing great with this one. Minus 1.29. And our next one am where I'm at. Now, these ones are your two secondary references, right? So they're going to be out in the middle of wherever. Angle 345 degrees, 21 minutes, 20 seconds. And that's sort of like that one was the post, maybe, or was that the square? That was the little square that's out there, right? And I'm just trying to put it in somewhere where I can go back and reference it later on. And that was 2.7, and its elevation was minus 1.33. And your last point, which we're going to use next week, where we're at 80.25 at an angle 351 degrees, 38 minutes, 0 seconds. And that one was the post. Or the corner of the wall or whatever. Oops, that was a copy, not a move. So this is really what you do as you develop your work. Now you're going to see that when you do the sim and you're using XYZ, man, it just pops in there. It's so quick. Super, super, super quick. But now let's just see. I'm going to draw a line from the end point of there to the end point of here to the end point. Oh, dang. Not too bad, huh? So you can do one now called, like a wall. That's that's pretty darn good for a first time. That's really amazing. A dash wall. I'm gonna make it. Um, I'll make the wall blue just to give it a different color for right now, and I'm gonna give it a little bit of a line weight. So let's put your wall in. There you go. Now, it would be really cool. That's probably supposed to be a 90-degree angle. Do you want to test it out? Angle, measurement. Let's just check it out here. Let's do an annotate angular measurement. Oh, it's within a degree for sure. What's that? Oh, what happened? Oh, you were able to get it out? Okay. Oh, I wonder what happened. Right. Yep. Right. Yeah. Oh.